Greetings, everybody. This is Distance Learning Week number 7, the quadratic formula. Learning target for today, I will apply the quadratic formula so that I can solve quadratic equations with irrational solutions, which are the non-perfect square root values. Okay. First, we talked about solving quadratic equations. Basically, your quadratic has an x squared term, could have an x term, and it could have also a constant. But you definitely need that x squared term. And what we needed to do is factor the quadratic equation, or quadratic polynomial, into two binomials, or depending on, it could also be a monomial and binomial, depending on which terms you have. And then from there, this was from last week, after we factored the quadratic trinomial, remember, you could either be, you may need the greatest common factor, and we do the reverse box. Once you get your two binomial factors, set each binomial factor equal to 0, and then you solve for x. So in one case, 2x minus 1 is one of your factors, set it equal to 0. We found out x is equal to 1/2. Now remember, you cannot write x minus 1/2 equals 0. That's not going to work. And similarly, x plus 7 equals 0. Solve for x, subtract 7 on both sides, x is -7. And voila, here's your solutions as a set. So that is here, and usually you would include the x equals part, which, sorry about that, x equals -7 and positive 1/2. Now, let's look at this polynomial, or quadratic. Can we solve this by factoring? What does the graph look like? So the question is, 2x squared minus 4x minus 5. Remember, this is your A, B, remember, include your sign, and C, again, include your sign. So are there factors of A times C, 2 times -5, which gives us -10? Do they add up? Are there any two factors add up to -4? Well, remember, you could have 2 times -5 or -2 times 5. Those two values will not add up to -4. You also have 1 and -10 or 10 and -1. If those values up, that's not going to equal -4. So, no, not possible. This is not happening. But we notice here, here's your graph. There are still two roots for this graph, because here's your x-axis, or y as well, and we notice that our parabola crosses the x-axis in two spots. So now, what is the quadratic formula? Well, for formulas, you substitute your values. Yes, use parentheses and apply germ das. So basically, you will follow, well, where ax squared plus bx plus c equals 0, and a cannot equal 0, otherwise you don't have a quadratic. And then x equals -b plus minus square root of b squared minus 4ac all over 2a. And there's a song similar to Pop Goes the Weasel in order to remember how you apply the quadratic formula. So x is equal to -b plus or minus the square root of b squared minus 4 times ac all over 2a. So that's basically how you could remember the quadratic formula. So let's take it one more time. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So this will be a formula we will use for the rest of this period, one way, shape, or form. And I will tell you how this formula can be our best friend when it comes to quadratics in multiple ways. Stay tuned. You'll find out in a little bit. So, using the quadratic formula, you will get your quadratic formula into standard form, or quadratic equation. There's our standard form. Ax squared plus bx, in this case, b is negative 4, plus c. C in this case is negative 5. Of course, I can't forget a is equal to 2. Know your ABCs. That's very important, especially for your quadratic formula. To be x equals negative b plus minus square root of b squared minus 4ac all over 2a. Now, I'm going to show you the next step, what we need to do. So basically, you first substitute. So that would be step number 1. Substitute first. Now, be very careful. Because right away, notice, you see a negative b here. However, just because our current value of b is negative 4, that does not mean you write a single negative 4 and that's it. You do need this other sign. I want to tell you right now, that can be that's where major mistakes take place. So right here is a key step. Because you need that minus negative, because when you do the minus negative, that's a positive. So you need to be very careful first step right away. Another dangerous mistake that could take place. Negative 4, whole thing squared. You need that negative 4 in parentheses because there is a difference between negative 4 with the parentheses squared versus negative 4 without the parentheses. Negative 4 with the parentheses, that's negative 4 times negative 4. That's going to give you a positive 16. However, negative 4 squared without the parentheses, that negative does not get canceled out. You still have a negative, and it's going to be negative 16. Now, another way to think about it, what if there was some number right here? Let's pretend this is a 0. And then 0 minus 4 squared, which in the end, 4 squared is 16. So really, you're saying 0 minus 16. So some of you, I think some of you may have had Miss Hoffman last year for math. May have told you that trick of, okay, you see a negative without the parentheses, put that 0 there. So then you realize this is like a subtraction problem. Now, another part I need for everybody to look at, right, as you substitute. Another reason why you use parentheses, again, this part right here. When you substitute, notice how this first minus sign right here between the b squared and 4ac, that has to stay. But notice here, you have it. In the end, you have a negative or a minus 4 times 2 times another negative 5. You have 2 negatives. So you have a negative 40, but you're subtracting a negative 40, which really, that just becomes one big plus sign. So that minus negative 40 becomes a plus 40. So really, in the end, you're adding 16 and 40, and your result is 56 under that square root sign. So again, that is one of the most important parts of this whole problem. So if you do your substitution, number 2 is evaluate. Evaluate, which 16 plus 40 is square root of 56. And then the third part, you will need to simplify your radical. Simplify radical. That's what you need to do next. If possible, sometimes you might not. Radical if possible. And then, after that, your last step, you may need to simplify your overall expression, which here you can do some simplification, not a whole lot. So you have to look at all the numbers. What's the greatest common factor of all three numbers? So in this case, it's 2. So then this 2 becomes a 1. This 4 becomes a 2. This 4 becomes a 2. And then you're left with 2 plus minus square root of 14. Because remember, simplify the radical. Remember, that's the birthday cake. That was before we left school. 56. 2. 28. 2. 14. 2. 7. And then 7. And then 1 to top off your birthday cake. And from here, this pair of 2's, 2 times 2 is 4. So that's where this 4 comes into play. And then you have 7 times 2, which is 14. And that's where this 14 comes into play here. So that's birthday cake method. That was before we left school. We did these types of problems. Now, one thing I will say, you do have to be careful. You might think, oh, can I factor this a little further, simplify? You can, but I mean, you may have to split it up. You may split it up as 2 over 2 plus minus square root of 14 over 2. You may be able to do that. Now, one thing I will say, in the end, you're probably wondering, Mr. Connors, on the previous page, there was 2 solutions. But on this page, so we see solution 1, solution 2. Why do we only see one big number here on the bottom? Okay, the reason is this plus minus sign in the end makes your problem, you still have two roots. Those roots will be the following. X equals 2 plus square root of 14 over 2. And then, oops, I almost ran out of room. Sorry about that. And 2 minus square root of 14 over 2. So that's where we get our two solutions. This plus minus, I just write it for shorthand, but in the end, if you have to list two solutions, you would list 2 plus square root of 14 over 2, then 2 minus square root of 14 over 2. And we see that here. Those are our solutions. Now, Desmos will give you the decimal approximate solution. So you will see. So on MathSpace, you will have to use the radical form. Decimal form, you'll see that more on Desmos. Remember, you can always use Desmos to help you figure out your solutions roots by typing in the equation y equals, in this case, 2x squared minus 4x minus 5. And then with Desmos, you can also do the following. You could set up your A, B, C with your sliding scale. And then you type in the formula negative b plus square root b squared minus 4ac over 2a. And similarly, but you would have to do it again. Almost the same, negative b, but now you have the minus sign, then square root of b squared minus 4ac over 2a. So then you see your two solutions for your quadratic. So what we're going to do, I'm going to give you all a moment to find the solutions for the following quadratic equations. Now you can use Desmos to help. Now, the first one, if you want, you can type in y equals 2x squared plus 5x minus 9. Now for this problem, notice how not all your terms are on the left side of the equal sign. So you would have to add 5 and then add 5 here as well. And then your result will be the following. Y, you can type this in, Desmos, I'm sorry. X squared, oops, sorry about that. X squared, then it's, oops, sorry about that. My computer's acting a little slow. X squared minus 6x plus 9. You can type that expression into Desmos as well. However, if you do that, you will get decimal values, and I'll talk about those momentarily. Yet, I also want to show you the quadratic formula in action. So for the first problem, I'm going to actually narrate this part of the whole problem. So identify your ABCs, -2 for A, +2 for A, +5 for B, -9 for C. Then you plug into your formula. B in this case is 5, so we have minus, then parentheses 5, plus minus, under the square root, 5 squared, minus 4 times 2 times -9, and it's all over 2 times 2. So now, of course, minus parentheses 5 is just minus 5. Keep your plus minus sign. 5 squared is 25. Now I highlighted this section blue. -4 times 2 times -9. Two negatives make your positive. And 4 times 2 is 8. And 8 times 9 is 72. So these two negatives make it positive, this term. And then you add 25 plus 72. Your sum is 97. Now, 97 we cannot break down. So we will leave 97 alone. So then your result will be x equals -5 plus minus square root of 97 over 4. Again, 4 is your 2 times 2. And then your solutions would be x equals -5 plus square root of 97 over 4 and -5 minus square root of 97 also over 4. And one root must be positive, the other root must be negative. Well, the sign in the middle. So here, this value, -5 stay the same, but you do have to list the positive and the negative. So again, you substitute, then evaluate. Again, watch your substitution, especially those parentheses. And you'll see why in the next problem. So a graph, there's your graph of the same equation. And then your solutions, x equals -3.712, 0, and 1.212, 0. All right. For the next problem. This one, first off, you have to add 5 to both sides. So you have your x squared minus 6x plus 9 equals 0. A is 1, B is -6, C is 9. Now here is where you need to be careful right away. I'm going to tell you right now, this first step, when you substitute right here, notice how B is -6. But there's already a negative here. So in the end, when you have minus, then parentheses -6, this, just like before, becomes one big plus sign. So we have 6 plus minus, well, -6 squared. Again, watch your negatives include parentheses. So just like before, -6 squared, you get a positive 36. But now, we're going to multiply by -4 times 1 times 9. But notice how this product is also 36. So we're subtracting 36 minus 36 in the radical sign. So in the end, well, 36 minus 36, that's just 0. That's okay. You could have a value of 0 under the radical sign. That's fine. So since that's the case, if we go back to our original problem, we have 6 plus or minus square root of 0 over 2. Now, since we have a 0, this term, both plus and minus sign go away, because if you add or subtract 0, your initial value doesn't change. So now we have x is just equal to 6 over 2. And 6 over 2 simplifies to 3. And since we only have one 3, x equals 3 is our only